Let's explore polymorphism in Python, a powerful concept in object-oriented programming. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It provides the same interface but with different implementations. This involves method overriding and method overloading, enabling more flexible and reusable code. There are generally two types of polymorphism. Compile-time polymorphism, which is achieved through method overloading, where the same method name is used with different parameters. While Python doesn't traditionally support method overloading, you can achieve similar functionality through default arguments and the use of *args and quarks. Then there is runtime polymorphism, achieved through method overriding, which involves redefining a method in a derived class. Subclasses override methods from their parent classes to provide specific implementations. Here's an example of method overriding. We have a class called animal with a method called speak that returns the string, animal makes a sound. We then have a class called dog that inherits from animal and overrides the speak method to return the string, dog says woof. Similarly, the class cat inherits from animal and overrides the speak method to return the string, cat says meow. Here's how we use polymorphism with method overriding. We define a function called animal_sound, which takes an animal object as input and prints the result of calling the speak method on that object. We then create instances of the animal, dog, and cat classes. When we call the animal_sound function with each of these objects, we get different outputs. Animal makes a sound, dog says woof, and cat says meow. This demonstrates polymorphism in action, where the same function call results in different behavior based on the object type. Duck typing is a concept where the type or class of an object is less important than the methods or attributes it defines. It embodies the principle: if it walks like a duck and quacks like a duck, then it is treated as a duck. In Python, you don't need inheritance to implement polymorphic behavior. Any object that implements the required methods can be used interchangeably. Here's an example of duck typing in action. We have a class called duck with methods swim and fly. Then we have another class called airplane with a method fly. Next, we define a function called make_fly that takes an entity as input and calls the fly method on that entity. This works for any object that has a fly method, whether it's a duck or an airplane. Polymorphism offers several benefits, including code reusability and easier maintenance, flexibility in design, enabling a single interface with multiple implementations, and ultimately resulting in cleaner, more extensible code. In summary, Python achieves polymorphism through method overriding using inheritance, and through duck typing, which focuses on behavior rather than strict type requirements, offering a Pythonic and flexible implementation. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.